All right. So let's say that we were successful with everything that the panel before just talked about, and we gained control of our 401ks, and we gained control of shareholder votes, and we dug in on the question that Leo Stein raised about corporate political activity. What would we do with that power, and how would we actually create a low-carbon future? Many of us think we know the answer to that question, but what we're going to do interactively today is really explore that seriously using a tool we developed at the MIT Sloan School. The starting point for this is to remind ourselves where we are in the big picture. Raise your hand if you have seen this picture before. My slides are not advancing. Okay, so instead what I'm going to do is I'm just going to go straight to the question I want to pose to you. What do you think is going to help us solve global climate change? How are we going to get to a future of no more than 1.5 degrees Celsius? I want you to take out your phones, open up the URL that's at the top of the screen here, pollev.com/JasonJ, and I want you to share your thoughts. This is a word cloud poll, so you should answer with one word or a hyphenated phrase. So if it's a 2-word thing, put a hyphen in between so that your responses stay together when you put your answer into the tool. We might ask you to log in or share, information. You don't need to do that. You can skip the login, whatever. What action will help us limit warming to no more than 1.5 degrees Celsius? And I imagine you can think about this broadly, right? As you are. Excellent. So we've got some technologies coming in, like fusion and fuels. We've got political processes like collaboration and partnership. We've got a bigger picture changes to our capitalist system, like degrowth and boardroom changes and a new economic imperative. So we need systems change, not climate change, as many of you may have seen on protest signs. So this is fantastic. This is the array of solutions that we need. Now, if you put yourself in the shoes of a top decision maker, which could be those Congress people or boardroom directors or C-suite executives or investors, and you ask the question, what do I need to do to solve climate change? This is the answer that you get. Okay? And your bandwidth for attention is about this wide, and you're worried about the Ukraine war and inflation and 15 other issues, and then you've got this much potential bandwidth to think about the environment, and then you've got water pollution, air pollution, and you've got this much to think about climate. And within that aperture of attention, this is the answer that you get. So how do we make discernments among all these different possible actions of how we might tackle climate change? We've got vegetarianism, we've got investment, someone seems to want to go to Mars, it looks like. A few folks have suggested electrification. So what we're going to do is we're going to just jump right in and start trying those things. This is an interactive simulation tool called En-ROADS. It's free, available for anyone. It's open source on the web. You can't load it on your phone, but when you have a laptop or an iPad, you can. It is parameterized to the best available science. We just did a new big model release so that it includes the Inflation Reduction Act and some of the more recent changes. It's a globally aggregated model, which means that when we make changes together here, we're going to be running experiments, and we're going to be doing it at the scale of the whole world, as if everybody did what we're going to try. So let's see. So we've got, one of the things here is policy regulation, so that's kind of broad, but here's the first one I see here that in big letters is electrification. So let's take a look at what happens if we electrify. So what I can do is I can electrify transport, and I can electrify buildings and industry. And what I want you to do whenever I make a change like this is to make a little prediction in your head about how big the change is going to be, and then we'll see what happens. So let's start with electrification of transport and increase that. So we can subsidize both the charging infrastructure and the vehicles. There's some electrification that's already going to happen, as you can see in these projections through 2100. And let's see what happens if we do a pretty significant increase in that electrification. Okay, so that gave us, we see this a much faster increase in electrification than we would have otherwise. If we look closely and we do our little replay button, you'll see that the band of oil here on the left is decreasing a bit. Our band of renewable energy is expanding. As a result, the greenhouse gas emissions, the fossil fuel CO2 emissions in the gray on the right here are decreasing. And as a result, we're getting 1/10 of a degree of avoided future warming. Raise your hand if that was a smaller change than you thought it was going to be. Okay? About what you expected? Raise your hand. If that was a bigger change than you thought it was going to be. Okay, so the average is that was a slightly smaller change than folks expected, but I want to get us into a little bit of a habit here, okay? We're going to solve global climate change in the next 14 minutes and 12 seconds. So every time that we get like 1/10 of a degree of improvement, I want to whoop from the audience. Is that okay? So we electrified transport. Now notice that what are the reasons why that maybe didn't have as big of an effect? Well, one thing that's going on is if we look very closely at our energy sources, there's actually, which will be a little bit easier if I bring it up in this graph form, is that when we electrify, if we haven't done anything to improve the grid, we're actually slightly increasing the amount of coal that we're burning. And so we've electrified, but we haven't changed our fuel source. So we're getting some benefits from the greater efficiency of electric vehicles, but we're still on a coal-intensive grid. And in fact, we can see that even more vividly if we look at some of the impacts of, for example, air pollution. Our electrification change is actually making air pollution slightly worse. PM 2.5 air pollution, which kills millions of people around the world every year, is predominantly due to coal burning, so we want to be careful about that. So this is a first experiment, so let's see what else we might try. I'm going to take a look at our picture here. Nuclear power, okay, this one shows up here in pretty big letters, so that means multiple people have suggested it. So let's give nuclear a shot. So here what we can do is we can increase nuclear energy. And I wanted just to get in the habit here is that whenever we're running an experiment, you could think about this as a public policy change, like a subsidy or a tax. You could think of it as a corporate action in the form of committed investment, like companies going to 100% renewable, or a civil society effort, for example, to encourage nuclear power to address the concerns that people might have about NIMBY construction issues. So let's do a subsidy on nuclear power and see what happens. All right, so what we just did was that we increased the scale of the nuclear energy industry by a factor of 7 by 2080. Okay, so massive increase in the amount of nuclear energy. And we're running a replay here so we can see. And the effect on temperature is that we got 1/10 of a degree Fahrenheit, but not quite 1/10 of a degree Celsius. So maybe I just get like a whoop, but not, maybe a more mild one. So why is that? What's going on? So what we can do is we can look here on the left and we can see there's a band of nuclear energy is expanding, but what is nuclear energy substituting for? What is decreasing when nuclear energy is increasing in this picture? Just shout out what you notice. Renewables, right? So we're substituting one form of green energy or one form of low carbon energy for another. Plus, it takes a long time for that nuclear energy to ramp up. And in the interim period, we're continuing to burn fossil fuels. So that's 2 experiments. Now, someone says human extinction. Awesome. All right. So Thanos is not only in the room, but apparently is really good at poll everywhere to game the word cloud. So we're not going to pull a Thanos button here, but we can think about population. Of course, the intuition here is that population times GDP per capita times the energy intensity of GDP times the carbon intensity of final energy equals the CO2 emissions for energy. This is the famous Kaya identity. And so maybe if population were lower, so what are ethical ways other than snapping your fingers with the infinity stones would be to essentially just try educating girls and women in emerging markets, providing economic empowerment, providing reproductive health care, access, and education across genders. We know that those things work. We know that they're ethical. They achieve the SDGs, and they have the possibility of getting us to a future of an 8.8 billion population rather than a 10.4, and that's worth 0.2 of a degree. Okay, good, nice. All right, so you got the whoop going. So it's important, right? Now, some people feel that's, small. Why is that bigger or smaller than you might think? It's just important to notice that if we look at that regionally, that population bend in the curve is largely happening in other developing countries. So here we break down by US, EU, China, India, other developed and other developing countries. And you can see that that decreased birth rate in developing countries is the way that you achieve those kinds of benefits. Those are places where people are not burning a lot of carbon per capita. And so the effect isn't as dramatic or significant as some people might predict. Okay, so now that I've run a couple of experiments, you can kind of get a feel for what we're doing here. What I'm gonna do is I'm gonna put you in control of the interface a little bit more. So keep that browser tab open to the Polev, and what I'm going to do is open up this poll, which actually is a, sorry, let me pass to the next one, is a tappable image poll of the interface. And so the way this works is you will, on your phone, be able to tap on the interface where what you want Jason's next experiment to be in our conversation. And then what I will get to see is essentially where you are voting to make a change. And then that'll allow us to run a couple of more experiments. While you're registering your votes, I will well actually let me just give you a second to tap on what you would like to try next. You can start to see some of these pins and the counts for the votes in the different areas. All right, so we've got 6 votes for doing something about coal directly. So since this is an investor audience, there's a lot of different ways that we could go about reducing coal. We might tax it and so on, but what we're seeing in the investor community is a lot of concern about the financing of coal. So what if we could just cut off the lending and the project finance for coal-fired power plants? What if we could just essentially stop building new coal infrastructure? A global moratorium on financing coal-fired infrastructure. Don't shut them down, the ones that are currently running, keep the lights on, but as we go to expand access to electricity around the world, do it in a renewable fashion. Let's see what that does. Okay. That was another 2/10 of a degree of avoided future warming. And since I showed before the importance of coal to air pollution, we'll take a quick look at the air pollution results. So if we stop financing coal emissions, that's how many lives we save, okay? Very significant, right? So often, our emphasis in these conversations is on how do we add capital to the cool new green things, right? That's part of the sexiness of coming to a Greenfin conference. But let's remember that it's about, renewable energy is about keeping the lights on while we shut off the fossil fuels, right? Electric vehicles are about keeping our mobility while we retire internal combustion vehicles. So the real question is, what's gonna allow us to do that? Now, let me take a look at your votes. So that was one, lot of attention on that. Now, a couple of you have said, okay, great, excellent. So now we've got a lot more votes in here for a variety of things. 25 of you want to try pricing carbon. Excellent. So let's take a look at that. And for that, I'm going to do something a little different here. I'm going to open up a fresh version of the model at the same URL that any of you could access, where you could access the tool. And what I'm going to do is I'm going to try just carbon price by itself in a second after that one loads. So let's do a carbon price. Now we can look at the details of how high we want the carbon price to be. Give me a dollar value. What should the global carbon price be in this experiment? Shout some numbers out. $200. Any others? 201, 150. No, this is not an auction. Okay. All right, so let's try 150. That was a sort of ambitious right now. Just for reference point, the current European Union emissions trading system is trading north of $100. So this would be, but we are seeing prices at about 150 level in Sweden and Switzerland and a couple of other jurisdictions. So let's say that the rest of the world caught up to them. What would that help us achieve? Let's go. Okay, 4/10 of a degree. On top of all the other stuff that we were doing, okay? If we go to kind of the sort of fresh version of the model, which we'll do, I'll run this experiment, because I think that there's some internet connectivity lags here. we'll see what that looks like by itself, but that's an incredibly important piece of the puzzle, right? And let's just to rewind that, notice that the carbon price has two different effects. One is that it's reducing the overall height of the mountain. We're making energy a little bit more expensive, and as a result, we're using less of it. We're getting more efficient, right? So if we look at a graph, for example, of energy efficiency in buildings, we're seeing an improvement in that energy efficiency. If we look at electrification, we're going to see an improvement in that electrification because of that carbon price. And then we're also seeing a shift in the mix of electricity. So we're hitting the high carbon sources the most, we're expanding our nuclear and renewables, and those two things together have a really important effect. 14 of you wanted to try methane and other gases, right? So here what you can see on the right is that we've got greenhouse gas emissions from land use, energy CO2, and then the rest of these are non-CO2, so F gases, methane, and nitrous oxide. So if we do a substantial effort to reduce methane and other gases, let's see what that does. That's another 0.3 of a degree avoided future warming. Okay, so now we're getting quite a bit closer. And notice that if you want, when you play with the tool, you can break that out separately and look at agricultural versus energy emissions of those non-CO2 greenhouse gases if you want to run those kinds of experiments. We've got 13 people voting to work on deforestation, reduce deforestation. So here we've got the land use emissions. Now, there's also 12 of you who want to plant new trees, which is afforestation. Okay, they just came to a tie, excellent. So afforestation versus deforestation, right? They sound like they're pretty similar. So let's start by planting trees. So if we take all of the land where we might possibly plant trees around the world, let's say that we are able to plant on 75% of that land, okay? So this is truly a trillion trees program. Let's see what that does. Okay, that's 1/10 of a degree. A trillion trees is 1/10 of a degree. Now I want to whoop, okay, because we got our 1/10 of a degree, but just notice that if we look at the land, for example, we just planted in India and 1/3 worth of tree plantations, okay, and we got, for that, we got about 4 gigatons a year of carbon sequestered. At the same time that we're, even with the improvements that we made on the methane, we're still emitting 5.7 gigatons of CO2 equivalent in methane. So afforestation is really important. There's a lot of, I love trees. I grew up in Colorado. I literally hug trees because they smell like butterscotch, if you know what I'm talking about. But they don't allow us to put away quite enough carbon. But what if we stop cutting down the trees that we have, right? That's all this land use emission, particularly here in the 2020 to 2060 period. Let's see what happens if we reduce those deforestation emissions. Okay, that gives us another 1/10 of a degree. And it gets us below the 2-degree target that we set in Paris, okay? So I've still got 2 minutes left. We're already below 2 degrees. What's it gonna take to get us across the finish line? So we've got, let's see, 10 votes for, 10 votes for technological carbon removal, all right? 7 of you wanted to invent nuclear fusion. Now, so that's kind of a fun thing, so let's give that a try. So if we invent nuclear fusion, which is this new zero carbon energy, let's see what does that do? What does that allow for us? Boom, so we just added nuclear fusion to the mix. What did that do to future temperature? Absolutely nothing. Why? Why? Well, it's the same issue that we had when we subsidized nuclear, which is that it's substituting away from renewables and nuclear. We're trading off between green energy sources. Plus, nuclear fusion takes a long time to ramp up the entire supply chain, training all the workforce, getting through the NIMBY issues, building it up. So it's important for getting us to Mars. It's going to be important in the very long run energy mix, but it's not going to solve global climate change. In fact, that was one of the original reasons we developed En-ROADS, was to convince Bill Gates of exactly that fact. The last thing that people have voted for is technological carbon removal. There's a lot of interest on that. If you want, you can play with all the details here: direct air capture, mineralization, soil carbon, biochar. If we just do a portfolio of those innovations, let's see what we get. Okay, so that, if I put like 30% of our total potential here, that gets us another 1/10 of a degree. If we crank it a little higher, we might be able to put a little bit more away. But notice, just as I was suggesting before, the land use requirements, right? So we're talking about that green line is just using land to spread rocks on the ground, okay? We're gonna use an India worth of spreading rocks on the ground? I don't think so. So we might have to back that off a little bit. But what you see here is a scenario for 1.8 degrees. Now, those of you who are involved in climate transition risk planning and temperature alignment for financial institutions, one of the important messages here is that there is not just the 1.5 degree scenario or the 2 degree scenario. In fact, there's a whole variety of different pathways that can get us to 2 degrees or below. Some of them have a greater role for natural gas and others don't. So a more detailed, thoughtful, scenario development is possible through En-ROADS, and then you can use this and complement it with other tools like the ones that you see here in the exhibition that are more granular and more data-driven. But the important thing is that this tool helps us to imagine a future that otherwise might seem unimaginable. And that is actually the most important point. Is we can upgrade our quality of our conversations about this topic when we can be grounded in the data and science, and we can upgrade the quality of our inspiration and our motivation when we actually can see a future that's viable for our kids and grandkids, as Michelle Wu asked us to do. Thank you for your time.